So we need to learn the basic idea of the classification. And before we learn about the classification, we need to see the difference between classification and prediction. So in some cases, um, the prediction can be in different name, but let's see. First, about classification. What is classification? We call classification, it is to predict categorical class labels. So, categorical, it is discrete or nominal. Let's say we have this data. We have the attribute age. We have another attribute income. We have another attribute student. We have another attribute credit rating. And we have one attribute bias computer. So let's say this is one person or one customer. I know that the person's age is less than equal 30. And I know that the person's income is high and he is not student. And his credit rating is fair. So I can figure out from this one bias computer. So this is a kind of decision. So this decision, we call it as a target dimension. So if I know that the person with the age under 30 and the income is high and the student status is no and the credit rating is excellent, okay, from the data, I know that he didn't buy computer. This person, the age is between 31 until 40, the income is high, he is not a student, the credit rating is fair, and he bought computer. So using this kind of data, we can determine something. We can determine this categorical, whether it is no or yes. We call this is the discrete. We say that we want to classify the data, classify into no, yes. After we construct a model based on the training set. So we call this is the training set. And the values class label in classifying attribute. So we have this classifying attributes or the class label and use it in the classifying new data. So for example, I go to the store. Okay, my age is higher than 40. Okay, let's say my salary is medium. And then I'm not a student, no. And my credit rating is fair. So can you know whether I will buy computer or not? If we learn from this data, we will be able to do some classification. So some typical application is credit approval. So the credit approval, it will have like yes, no. So if you apply for the credit in the bank, they will approve or not approve. And then target marketing. So if you are a potential customer, okay, so there will be some profile, customer profile, age, and your income or maybe your status, your job, and etc. So they will determine whether you are a good customer or bad customer. And medical diagnosis. Now you know about the COVID-19 tests. Okay, we have the PCR test or we have another test. So they have a lot of measures. We can determine whether someone is positive or negative. Fraud detection. So if you use your credit card, there can be some fraud. So they can also recognize if they have a lot of attributes, whether it is a fraud or not. If we are dealing with the prediction, so sometimes some literatures they mention forecasting, or sometimes it is regression. So let's see the difference. If it is prediction, we want to model the continuous value function. That is, predict unknown or missing values. Sometimes it refers to forecasting or regression. Forecasting is a similar term with prediction, but it is intended for time series data. For the time series data means we have the time sequence. Let's say I have the data on January 2020. I have data on January 2020. And then I have February on 2020, March 2020. So let's say the demand is 80, and this one is the demand is 60, and then if this demand is 70. So in the April 2020, can you predict the demand? Yeah, there are some methods to know about what is the predicted demand by using forecasting. Regression. It is a method to predict continuous values. So for example, I have the computer price. So instead of the decision no or yes, I know if the computer price is 0, it means the customer didn't buy any computer. If there is a price, maybe this is a price in dollar, $1,350. Then, okay, the person bought a computer and the price is this one. So I can predict how much the price that the customer will buy. So if we have this continuous label, and this will be the target, we can use regression. In the previous example, I show you the supervised and unsupervised learning in image data. What about if we have the supervised and unsupervised learning in the record data? So we can say this is the supervised learning or the classification with the record data. This is record data. So the supervision, as you know, the training data or the observations, measurements, and etc. are accompanied by labels. So we have the labels here, indicating the class of the observation. So I want to know what is the profile of the customer who did not buy a computer. I want to know the profile of the customer who bought the computers. The new data is classified based on the training set. So this is the training set. If you have a new data, then you can classify based on the model that we get from here. The other one is, we call it as unsupervised learning. So clustering is the most prominent method. We call this is unsupervised because we have no label. Okay? The class labels of the training data is unknown. So we do not have any label here. So I do not know what is the decision. I do not know what is the target. I just know that this is the customer profile. So I can do something. Okay? So given a set of measurement or observation, the aim is to establish the existence of classes or clusters in the data. So I can check, or maybe the person with this attribute are similar. 30, 30, yeah, they are similar. Maybe because they are similar in the ends. Or yeah, we can also check the similarity in the other attributes. So we can just check the similarity, but there is no target. Okay? The target is unknown. So when we do the classification, there will be two steps. The first step is to make the model or to construct the model, or we call it model construction. It is to describe a set of predetermined classes. So every tuple or every sample is assumed to belong to a predefined class as determined by the class label attribute. So you can see here, every sample means every tuple or every row. Every row will have its label. The set of tuples used for model construction is training set. Okay. So this is the training set. The model is represented as a classification rules, decision trees, or mathematical formula. So we will learn about this one. The second thing is about the model usage. So we want to use the model. Once we know the model, we can classify the future or unknown objects. So as I mentioned before, I have this data, and then let's say I have a new data. 40, and then medium, and no, and then fair. What is the result? So we call this is the testing data. We call later this is the testing data. We want to use the model, and first we need to estimate the accuracy of the model. If the accuracy is good enough, then we can test to the known label of the test sample. It is to compare the classified result from the model. And yeah, we will check later the accuracy rate. The accuracy rate means this is the percentage of the test samples that are correctly classified by the model. Test set is independent of the training set. Otherwise, overfitting will occur. So we call this is the training set. In this model usage, we call it, we need to have the test set or testing set. So if the accuracy is acceptable, we can use the model to classify data whose class labels are not known. So this is the diagram to show. We have the model construction. It means the model is generated using the training data set. We have the data. So we split into two, training and test set. After we have the test set, then we can make a model. And in order to check the model, we use the test set and we can estimate the accuracy. So the second one is the model usage. It is to evaluate the test data set. It is to evaluate the test data set. There are some issues when we are doing with the classification. Okay. The first is the data preparation for the classification. So we learned many things about the data preparation before. Let's say we learn about the data cleaning. You still remember what is data cleaning? We want to reduce noise. We want to handle missing values. Or we can also find some features. We want to select some features. So there are some analysis. We call it like relevance analysis. We want to remove irrelevant or redundant attributes. We can use the method like PCA. We can reduce the column, or we can use some numericity reduction. We can reduce the rows and so on. We need to transform the data, so to generalize or normalize the data. For example, we have the attribute age. Okay. The attribute age is a number. Usually it is number from 0 until a particular number. Let's say the oldest human in the world maybe now is 120 years. Okay, this is the maximum. But what about the salary? Salary in Korea, the minimum is 1 million. Okay. Okay, let's say 1 million won. This is the minimum. But what is the maximum? We don't know. Maybe let's say 100 million Korean won. Okay. So the range value is very big. The range between the age is only from 0 until 120, but the range of salary is very huge. So when we do this kind of analysis, we cannot make a general model. So sometimes we need to normalize the data. You still remember normalize? We learned about the min-max normalization. We learned about the standardized normalization. Okay. So when we do the classification methods, we can also check the accuracy. So the accuracy means, we have the classifier accuracy. How we can predict the class levels, the accurate of the prediction, or the predictor accuracy. We call it how we can guess the value for predicted attributes. So the accuracy is important for the classification methods. Speed. It is the time to construct the model, the training time. So in my research, we have a lot of data. So we handle the data like until 5 gigabyte. You know, 5 gigabyte is very huge file. And the computer run to train the data like almost 3 days. And we can just get the result after 3 days. So it means the algorithm is not that quick. So we need to find some good algorithm to solve the problem in very fast. Or we need to consider also the time to use the model, the classification or the prediction time. If the model is good, but the time to use the model is big, then it will not be good as well. The robustness of the classification. It means that whether the model can handle the noise and the missing values or not. The scalability. Some models is very huge and some models can be very light. You need to consider the efficiency in your database. Interpretability. Can we understand the model? Is the model give you some insight or not? So it is also important for the classification. Yeah, there will be other methods like goodness of rules. For example, decision tree size and the compactness of classification rules. Okay, learning check. So today there will be also a learning check after the class. Okay. So let's discuss this first. What is the difference between classification and prediction? When it is about classification, it means it is to predict categorical label or class. What about prediction? It is model the continuous value function, and it can be to predict the continuous label or class. Okay. Mention the two steps of classification process. We have the model construction and model usage. In the model construction, we use the training dataset. For the model usage, we will use the testing dataset. What is the difference between supervised and unsupervised learning? Supervised means the observation or the data contain class label. Unsupervised learning means when the observation does not contain class label, and we can do, the aim is to cluster or create the label based on the similarity. Oops. Okay, so we will learn later what is unsupervised learning. What are the issues on the data preparation for the classification? We have three issues. The first is data cleaning. And then we have the feature selection or relevance analysis. And then we have the data transformation. Okay. What are the issues on evaluation classification methods? Yeah, we have this issue: accuracy, speed, robustness, scalability, interpretability, and some other measures. Okay. Okay. So let's move on to the next section. We are going to learn about the decision tree induction. What is decision tree induction? Let's suppose I have this training dataset. It is based on the examples from the Queensland ID3. ID3 means ID3 means induction decision tree. I don't know why they put the number here, but yeah, it may be just for simplification. So based on this training data set, I can make a decision tree. So we call this is the model, or this is the output. So if I know new data, let's say there is a new customer, he is more than 40, and he is not a student, and the salary is medium, and the credit rating is fair. Can you predict whether he or she will buy computer or not? We can check based on this decision tree. So first, okay, I know the age. What is the age? More than 40. Then I can go to here. After we go here, there will be a question, credit rating. Okay, what is the credit rating? Is fair. Okay, because the credit rating is fair. Okay, I know that he or she will buy computer. So because this is the decision tree. Now the question is, how we can create this decision tree? There is one algorithm. This is the algorithm for the decision tree induction. The basic algorithm is a greedy algorithm. The tree is constructed in the top-down recursive divide and conquer manner. Divide and conquer, I think if you learn their structure and algorithms, you will learn about this terminology. At start, all the training examples are at root. We call this is the root. Okay. Attributes are categorical. You can see here. Yeah. Maybe you can think that okay, it's should be number. Okay. But now we make the category less than 30, 31 under 40, or higher than 40. So it is the category. Income also category high, medium, low. Student also category no, yes. Credit rating also category fair, excellent. If it is continuous value, they are discretized in advance. So we need to make a discrete value if we have the continuous value. Examples are partitioned recursively based on the selected attributes. So we can select age first, then we will do the calculation. And then next we will select the income, and then we will do the calculation, and so on. As attributes are selected on the basis of the heuristic or some statistical measures. So we will learn about the information key. Some stopping criterion, the condition for stopping partitioning is when all samples for a given node belong to the same class. So if every of these samples or every of the rows belongs to no, then they are already in one group, then finish. We do not need to do more evaluation. Or the second condition is there are no remaining attributes for further partitioning. Yeah, maybe we already reached for the every no is already finished. Or the other condition is there are no samples left. So we already select all the samples and then finish. We will learn about the information gain. Information gain has been used in the ID tree, and there is another algorithm, we call it C4.5. We need to select the attribute with the highest information gain. What is this one? Yeah, we will check. Let Pi is the probability that an arbitrary tuple in D belongs to class C. It will be estimated by the Ci divided by D. Okay, maybe this is a bit difficult to imagine the formula. But what I want to mention here, the Pi is the probability. And we are going to calculate the entropy, expected information, or we call it the entropy. The entropy is the information that we can get from this formula. Minus sigma Pi is the probability or the proportion log base 2 of Pi. And then we will do the summation for all the classes. We will check the information needed after using A to split D into V partition. So we will check the proportion of the data multiplied by the I or the info T. The info T is from here. And we will check the information in. Okay, we will check with examples. Before we go to the examples, I want to explain what is the meaning by the entropy. Entropy is the degree of disorder. Yeah, this one is the Korean. 무질서의 정도. Let's say like this. I have coin. You know, coin. So in coin, if we have one coin, we can have two sides, front and rear. Let's say I toss the coin. Okay. So when I toss the coin, there might be, maybe I toss two times. Okay. The first is front and the second is rear. Then what is the probability, the occurrence of each of this one? From two times, there is one occurrence for front and there is one occurrence of rear. Then we can say 1/2 and 1/2. So the entropy value will be minus half 1/2 log base 2 1/2 minus 1/2 log base 2 1/2. And we can get the entropy value is 1. When it is 1, when the entropy value is 1, it means this is the top. If it is the top, then we can again classify whether it is 0 or 1. Let's say another example. If I toss for 2 times and front it happens 2 times and the rear it happens 0 times, then among 2 times are front, so the probability is 1. 2 divided by 2. Then the entropy value 1 multiplied by log base 2 1 plus minus 0. Okay, 0 multiplied by any value will be 0. So 1 log base 2 1, it means it is 0. So the result is 0. So if you look at this one, because it is 0, we can look at this one. This is only front that happened. Then we don't need to separate because I know this is only front. So let's say with the other example, if I have 2 coins. If I have 2 coins, then there is a possibility front and front, front and rear, rear and front, rear and rear. So if I have the same times, let's say I want to toss the coin for 4 times. And if it happens front and front 1 time, this happens 1 time, it happens 1 time, it happens 1 time, then the probability will be equal. Okay? 1 divided by 4, 1 divided by 4, 1 divided by 4, 1 divided by 4. Then we can make the entropy value with this function. So the entropy is 2. This is because we have 2. Okay. If suppose we have this probability 1/8, 1/8, 2/8, and 4/8. Okay. So it means from 8 times, it happens 1 time, it happens 1 time, it happens 2 times, and it happens 4 times. So the entropy value is this. But if among, maybe among 8 times, it is 0, 0, 0, and this one is 8 times, then we will get the entropy value is 0. So if it is 0, then it will be only in one class. It will be only in one occurrence for the class. Now we will check, okay, whether the data has high entropy or low entropy. So if it is high entropy, then we can later split. If it is low entropy, then we cannot do more split. Let's see with detail. I have the, this is the data. Now I can make the class P and the class N. Let's say the class P is the bias computer yes, and the class N is by the computers no. So I can make the expected info or the entropy for P and N. Let's say if I do not know the age, I do not know all the other attributes. So the positive is 9. How can we get 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. We have negative is 5. How can we get 5? 1, 2, 3, 4, 5. Okay. So the total we have 14 data. So the info T, it means the information kin for the whole data set. We can use this formula, and this is the way to calculate it. 9.5, it means the P is 9 and the N is 5. It will be minus 9 divided 14 log base 2, 9 divided 14, and then minus 5 divided 14 log base 2, 5 divided 14. And we can get the result 0.940. Next, we want to select the attribute. What is the most possible attribute, or what is the most important attribute? Let's use the X information. Okay. The orange color is the X under equals to 30. So I want to check how many P and how many N. So 30, under 30, this is no. 1, no. 2, no. 3, okay, this is yes and yes. So we have 3 no and 2 yes. And the S less than equal 30, we have 5 rows. Okay, we have 1, 2, 3, 4, 5. Now let's see the next. 31 until 40. This is the green color. 1, 2, 3, 4. Okay, we have total 4. And how many yes? We have 1, 2, 3, 4. Okay, we have 4. And how many no? Nothing. So it's 0. What about after 40? Above 40, we have 1, 2, 3 yes. And we have 1, 2 no. So the total is 5. Okay. From this one, we can calculate the information gain. How to calculate the information gain? It is the same with the previous one. We can do the calculation I because we know the number of p and we know the number of n, and we know the total number. The total of h is 5. The total of 31 until 40 is 4. The total about 40 is 5. So we can make the calculation. When the h is less than equal 30, we have the I 2, 3. It means minus 2 divided by 5, log base 2, 2 divided by 5, minus 3 divided by 5, log base 2, 3 divided by 5. We get this value. And then we need to do the next one. We need to do the 31 until 40. Because the one side is 0, yeah, we have the entropy value is 0. And then we have the attribute higher than 40, 3, 2, so the result is the same. And we need to get the entropy value of the attribute H. How to get this one? So we need to make the proportion. So this is the proportion of the first category, which is less than equal to 30. We have 5 among 14 multiplied by I 2, 3, this value. And then 4 divided by 14, it means the second category, multiplied by I 4, 0. Because it is 0, then yeah, it will be 0. And then we have 5 divided by 14, this is the third category, multiplied by the I 3, 2. So this one. So you can just multiply and then you will get the value 0.9694. Then what is the meaning? This is the information gain for the attribute H. After we have this information, we need to subtract with the whole information. What is the whole information here? We need to get the info D. The info D is the total data from the 14 data minus by the information only on the attribute H. So it means what we got 0.940. How we get this number? This number is from this one. This is the info D from the whole data. Okay. And we want to extract it with only the information value for the attribute H, which is 0.694. Then we will get the value 0.246. So this is only the attribute H. We need to do next for the attribute income. We need to do next for the attribute student. We need to do next for the attribute credit rating. And then we will get all the gain value. When we did the calculation for the H attribute, we got 0.264. If we do with the gain income, we get 0.029. If we get the student, we get the value 0.151. If we get the credit rating, we will get the value 0.048. So among those numbers, we need to select the highest information key. The highest is it means the highest information gain is the most discriminating power with regard to the target attribute. So the H is the most important attribute, or the edge is the most discriminating power to make the next split. So after we have this edge, we will check again. So we get student. What about this one? 31 until 40. We do not need to check because it is already clear. We have 4 and 0. We cannot split anymore. What about the credit rating? Yeah, we can, what is the result if it is higher than 40? Okay, we can use the credit rating, which is the highest information hint. So we can split with the attribute whether it is excellent or bad. Okay. So the calculation is the same, and it should be for every of this attribute. Okay. Let me stop here. Okay. Let's have a break.